Hello everybody and welcome back for another installment of the X231 Restoration Series. As you can see from the parts that are on the bench, it's time to look at transmission, shift forks, and rails. I have the prototype pieces here, production pieces there, and although at first glance they pretty much look all the same, I assure you there is way more to it than what meets the eye. So we'll do the typical compare, contrast, assess condition, and see where things go from there. I mean, it seems like I always find something with this tractor, but anyway, stay tuned. So the first thing I'll do is just look at the basic layout of these forks and shafts, and I can tell you right now that there really isn't a ton of difference in the general layout between the prototype, which is back there, and the production forks that are up here. There are differences, like I said, but before I get into that, I can tell you I've got these laid out in the same order that they would be installed into the transmission. So to kind of give you a better idea, that is the same way that they would be installed in this same sequence. I also labeled what each one is for. This very long curved fork that goes very deep into the transmission is for first and fifth gear. This next one over is second and third. This fork engages fourth gear, and finally on the end here we have reverse. Now in order to do a comparison, I'm going to disassemble these, and all of these pieces are held onto the shafts by roll pins, so it's pretty easy to knock them apart and get them put back together again. And they usually, if everything is free of burrs, slide off of the shafts without a lot of effort. So now that I have both sets disassembled and laid out next to each other, it doesn't take a lot of imagination to recognize that for the most part, the major dimensions are all the same. Their styles of construction differ greatly, but for the most part, they could be stand-ins for one another. And I say for the most part, they're not 100% interchangeable, but we'll get into that later. I've looked at all of the prototype pieces, and I don't find any 10x numbers, no identifiers on any of the forks nor the lugs. The production ones do have numbers on a couple of pieces. I have a very faint 10A 9880 on the large first and fifth fork. Nothing that I can see on the second, third. Fourth, we have a 10A 9882, and again, nothing on reverse and nothing on the lugs. But as the parts manual would have it laid out, it goes 10A 9880, 9881, 9882, and then finally 9883. So now I want to do some side-by-side comparisons here between the prototype and production. Like you can take the first and fifth gear fork. Here's the production version, of course. It looks like it's a cast steel, all one piece. We have some raised lugs down here for engaging the gear, and I can tell by the discoloration of the metal that they've been hardened, which is, you know, something you would certainly expect. But you look at the production one, and it's all handmade, pretty much just out of flat steel, and then we have this round collar that was welded on the end. And here's the kicker. I haven't found any traces of hardening at all on this fork. I can take metal right off it, just easy as can be. So considering this wasn't even a hardened component, it's held up very, very well for how many hours are on this tractor. You can see a little bit of wear starting here where it engages the gear. Same on the other side, but it's not excessive, and this is a drop-in, ready-to-go piece. It's not bent, it's not ruined. I'm really amazed. And I also like how they mimicked the design in every way on the production piece, right down to the reinforcement spine that goes down and gives it some extra strength. They even cast that in, and basically everything is just the same between these two pieces. For me, this prototype fork is, like, seriously guys, it's like a piece of art, and if I wasn't going to try and put it back in the tractor, I'd hang it on the shop wall just to admire it. And I'm serious, I'd hang this right on the wall. It's just really, really a neat piece of engineering. You can also look at the other forks. Here's the second, third. We can see pretty much offsets are the same. This one's been broken and welded, and this one tells quite a story. We'll get into that later, but you can see they added a little bit of a reinforcement right there. I think they realized it needed a little bit of help, a little bit of extra strength, but for the most part, those are the same. Again, mild steel, and this one has been hardened down where it engages the gear. And same for the other ones. Here's the fourth. We have a little bit more reinforcement on this one, but otherwise, you know, pretty much all same size. They just do the same flat steel welded to a tube. And again, same for reverse. You know, a little bit more reinforcement there, but for the most part, this one also held up very, very well. So now the final bit of comparison between components, we'll just look at the rails for the forks. For the most part, overall length is the same. For the most part, detent ball grooves are in the same spot. The biggest difference is roll pin bore locations. But biggest single difference I found on any of these is for the second and third gear shafts. We have a little bit of difference in distance between the neutral position and the second gear engaged position for those detents. So travel will be a little different on those shafts, as well as, again, the roll pin bores, but otherwise overall lengths are pretty much the same. So that's really the main differences between the rails between the prototype and the production. So now that we've had a pretty good look at everything, what I want to do is a dry run assembly, see how everything fits, and see how it all works. So I'll start with this large first and fifth gear fork. It's the most difficult to get into position. There, it's engaged with the gear. Feed the rail in. Start it through the fork. Put the shifter lug on there as well before we get it too far. And now I'll go clear to the other side and drop that reverse fork in. Again, feed the rail. Now this is the point where I would normally install the 2-3 shift fork with the rail, but I've found some pretty bad problems with those pieces, so big surprise. We're just going to leave those out for now, and instead I'm going straight to the fourth gear fork. And once again, feed the rail through it. And install the shifter lug. Okay, now that the rest of those are in, I'll just I'll show you why I chose not to even mess with the 2-3 fork or rail. Slide the rail in here, and you can see on this end here it is so bent it does not even come close to engaging with the hole that's on the other end of the case. And when they're that bent, it doesn't even pay to try and do anything with them. And also remember, this is the fork that was broken and welded once already. So that should kind of explain why that rail is in such poor condition as well. So we'll just leave those out for now, but I want to test the condition or the fit and function of the 3 that I'm suspecting are still good. So I'll start by dropping the detent balls into the holes above the 3 forks that are in there. And I'll also take the detent spring, drop in above each one of them. And what that will allow me to do is to put a little bit of down pressure on those detents and ensure that I have those 3 rails centered in the neutral position. Now to do a quick function test. For the life of me, I'm not sure how to set the camera up to capture everything that's going on, but what I'm going to do is use this punch to simulate the roll pin one at a time to ensure that I have the fork lined up with the rail. I will be manually applying pressure to the detent, so I know the rail will be in the appropriate spot, and we'll watch the pinion shaft down here and test all the different gears and see what we've got. So right now we're in neutral. I'm spinning the input shaft. Nothing's happening down here, so that's good. We have no gear clash. I'll see about first gear, so I'll roll this back. Sometimes you need to, there we go, turn it a little bit to help engage. Push down on the detent, and you can see we have some very slight movement on the pinion indicating we are in low gear. So we'll move this back forward. There's neutral, we'll go for fifth. That should be fifth. And yep, you can see the pinion turns a lot faster. So that's fifth. Okay, we'll pop that back to neutral. Good again. Now we're going to check fourth. So I'll line up the fork with the rail with the punch here. We are in neutral. So let's manipulate fourth. There we go. Pressure on the detent. And we have fourth gear right there. All right. Pop that back to neutral. Once again, good. And now we'll check the reverse. Again, line the fork with the rail. Pressure to the detent. There we go. And yep, we're going the other direction now. So we have reverse. So I know all three of those forks and rails are going to work just like they should. So after the function test, I can conclusively say I feel pretty good about the three sets of forks and rails that I just tried in the transmission. So we'll go now to the second and third gear assembly, and I'm just trying to decide where to start with this because everything I look at is really bad. We'll just start with the rail. We know it's bent. I can tell you without a doubt that second and third gears were the most used in this tractor during its working life. You can tell by how worn the rail is, where the detent balls would hop between the grooves. So they not only wore it on this side, but then they flipped at 180 and they wore it even more over here. We have an interesting thing that I see right here where they've taken, this will be the third gear detent groove. They have ground extra relief up top, so it's like they're trying to increase their rearward travel on this rail by giving that detent ball a spot further out toward the end to rest in, and then they even built up the reverse slope of it with, it looks like some brazing, it looks like brass. So that's something we need to look very closely at the third gear mesh going on to see what they were trying to correct by making that little alteration right there. So I'm pretty much writing this shaft right out. It's got too many bad things wrong, going on with it. We'll look at the fork now, and like I pointed out already, it's been broken and welded. It has not been welded very well, and if you take a look at how everything lines up, you can see how we have the collar that goes around the rail is pretty much straight up and down, but we are not square back here with the rest of the fork. Instead of being square with it, it's canted like that. It's pretty easy to see. So either this piece got bent or it was not welded on in exactly the same position that it started life in, or maybe both. So we have that's going against us. We have another crack starting right here. Only goes in about that far that you can see, but that would still have to be fixed. From when this broke, it looks like we have a witness mark here where a gear tooth came in and bound down on it pretty hard. We've got another mark here, a couple more gashes there, another one there. And from this not being a square assembly anymore, from this being cocked that way, just as you would expect, we have profound wear on this leg of the fork on this side from it not being square in the sliding gear groove. We have some pretty good wear from the teeth right up there, and then on the other side we have profound wear on the back side of the other fork leg. So I'm not sure what to do with this. I can't even fit this in the transmission to check function. So because the production version is so close to being the same dimensions, for now I'm just going to pop this production rail and fork in, and we're just going to test second and third and see how this works. Try and make a plan of what we want to do from there. And fortunately, the second and third gear mechanism is a pretty simple one to observe. The fork just goes in that groove that's in this sliding gear up top. Feed the rail through. There we go. Drop the detent in. That should be the neutral position. And now I'll roll this around, line my punch up to simulate the roll pin, which locates everything. All right, we are neutraled out once again. So for second gear, this whole assembly just slides forward like that, and this upper gear just meshes with the one below it. That gives us second. Now for third, there's neutral again. For third, if I can work the light just right, this sliding gear is just going to go and mesh on the inside of the gear that's right behind it. So to test that, slide it back. There we go. You see it slid inside that gear, and now we have third. So that is how second and third gears work. Now in a perfect world, I could just substitute this production rail and fork and everything would just be fine. But unfortunately, we do not live in a perfect world, and I'll show you what my problem is. So with the rest of the prototype rails and associated components installed, you can see that the tabs for my shifter quadrant do not all line up with one another. This production one is about 1/4 of an inch further back, and all 4 of these would need to be in perfect line with one another to have a good neutral sweep on your shifter quadrant. So what are my options here? I could always cut this tab off of the production cast steel fork and try and weld it on further forward. I don't really trust my abilities with that. I have some concerns because with these detent springs fully compressed when the shifter top is on, it takes such pressure at the base of the shifter to exert upon those tabs in order to unseat that detent ball and slide it to the next groove that I'm not confident that that piece wouldn't break off. And if it breaks off, I can just about guarantee you it's going to find its way between a couple gear teeth. So I really don't like that approach. So here's an option number 2. I still have the production rail in there, but I have put the damaged and repaired prototype fork on. And yes, this is the one that is bent and worn and has been welded and is out of shape and what have you. But it keeps the tabs in a nice row and a nice line for the shifter quadrant. My main problem with this though is that the drillings for the roll pins do not line up between the prototype fork and the production shaft. You can see I just have a sliver of that hole visible in the opening that's in the fork. So what I'd have to do is probably close off these old holes in the fork and then drill new ones, hopefully in line with the existing hole that's in the rail, and try and make everything work that way. But I'd still have to invest a considerable amount of effort and time into refurbishing and repairing the rest of this damaged fork and trying to make that right again so that it would be reliable enough to be put back in service. Or we've got option number 3. I just abandon this old broken fork altogether and make a new one just like it, which I'm pretty sure I could do and do well. But I'm definitely going to go with the production rail. Like I said earlier, the prototype one is just too far gone, the way it's been worn excessively on both sides. And then it's kind of interesting now when I look at the extra reliefs they were grinding up here and then backfilling behind it. They were trying to get this rail and this fork to slide to the rear farther to more fully engage that third gear into the one behind it. So this these marks right here tell me that they were having problems with this staying in third gear at one time. So if I made an all new fork, I would be very mindful of checking the position of the mesh of everything before I actually finalized it and then drilled it to fit the new rail. Or there's always an option 4, which would be the easy route, but it would involve going with all production rails, all production forks, putting a production 10A top cover on and a production shifter. And like I said, it would certainly be the easy way out, but the easy way usually is never the best way, and really don't want to do that. So anyway, this is where you guys come in. I want your advice. Option 1, should I just modify that production fork? Option 2, should I repair and re-drill the prototype fork? Option 3, should I just make a new fork altogether and be done with it? And I kind of think you guys know where I'm leaning with this already, but I'm soliciting your advice. I want your opinions. I want to know what would you do? And if I have not thought of everything, if you can come up with something that I have not yet listed, feel free to share that too. I am going to read the comment section. So as always, guys, thanks for watching. I await your responses and hope to see you back again.